pretty late in the day. Everyone's probably a little tired, under-caffeinated. So I promise I won't make you think too much. Just kind of gonna go over some history lessons, understand what cross-platform development really has led up to, some of the past projects that have focused on trying to make writing an app once and running it on all these different platforms, how they made that possible, and what we at Ionic have been trying to do to make this a little bit easier. If you want to follow me, M. Hardington on Twitter. It's probably the best place to get in touch with me. So yeah, history lessons, take a look at what the current landscape is, and then we're going to dive into our little project called Capacitor. So think back to 2007. The very first iPhone was released. Everyone was kind of excited because it was probably the biggest revolution in mobile devices. And I don't know how many people know this, but when the iPhone was first released, they said you were going to build amazing apps for this. And you were going to use HTML. And everyone at Apple was like, yeah, this is great. And everyone in the audience was like, no, this is horrible. Because the web at 2008 wasn't really that great. It still has some hairy spots today. So after they released the iPhone, a year later in 2008, they released the very first iOS SDK. Come to find out, afterwards, a year later, Android released their first version of their SDK. So to date, we have roughly 10 plus years of native tooling, improvements to those ecosystems, and different ways to make using native tools and native IDEs and everything else, make them easier. Fun fact is, the first day that they released the iOS SDK, there was this hackathon sponsored by Apple where they were just bringing all these developers and say, hey, here is an opportunity to talk to us, directly to us, and use this new technology and build something that was really cool. One of the projects that came out of that was, could we take iOS, a web view, and then load up a web app and then publish that to the App Store and still talk to the native APIs, things like notifications, prompts, accelerometer, geolocation. Could this have been possible? Could this be possible, and what would that code look like? So they were very successful, these ambitious hackers, and they created this thing called Apache Cordova. If you've heard of it before, chances are it's because you use our stuff. If not, you may have heard it called PhoneGap. No? OK. So we're just going to call it Cordova. And it really tried to push this idea of write once, run anywhere. They were probably one of the first real games in this space, and the first one that really gave any serious competition to, can I publish a web app on to the native app stores and still use the native SDKs when I need to. And its key thing that made this possible was this bridge technology, which listened to calls from a web view and then proxied that to the native APIs. So the same way that we kind of have proxies today with objects, or in JavaScript, it worked similar ways. And their goal was to just polyfill what the browser didn't support. So a lot of their APIs kind of mapped off of the navigator object that we saw in the browser. So for things like camera, you would call navigator.camera.getPicture. For geolocation, for accelerometer. They really pioneered these ideas and took early specs that were going through the web working group and said, hey, how can we help make this possible and get people to understand and use these APIs today? And their most ambitious goal was to cease to exist because they didn't want to maintain this code base. It was really difficult. It was kind of complicated. They just wanted to do something to help developers out until the browser caught up, more or less. So again, just a little overview of like what the actual architecture is. Inside of a web view, you basically have your web app. Now, when you make calls from that web app, it sends those out and emits it to the web view. Now, from that web view, it emits some data. Basically, what method are you trying to call? What data, what options do you want to pass back? And it sends that to the bridge. Now, the bridge will go through and actually proxy everything out to the hardware APIs, device-specific features, make those calls in native, and then send that data back to the bridge, and the bridge will publish it to the web view, thus returning that data to the actual web app. It's a real high-level overview. There's a lot of nuance in there, but at 10,000 feet, this is what it looks like. And some sample code here, because we don't really need to go too much into it. We have this navigator object. We are calling camera.getPicture. We have this node-style pattern of having on success, on fail, and then passing in options as the last parameter. Now, as we would call this, we would, again, publish that data from the web view to the native bridge, and then it would go out, present the camera, we'd get the camera data back, and then we could handle that however we want. So in this case, we're just grabbing an image by ID called myImage, and then setting the image source to a base64 string. If we failed for some reason, modern day OSs will have permission saying, hey, do you want this app to use your camera? You could say no, and it would fire that, that onFail function and just say, hey, the user failed, here's the reason why. Now, this would be a good example of how things worked when you wanted to call methods through interactions. But if you wanted to do anything exactly when the app started up, there's this really weird, I wouldn't say bug, but this really weird quirk of how the architecture works. We have this event called device ready. And basically, all we needed to know is that the bridge to the native APIs in the web view, that connection has been made. So we can start making calls to things, we can start getting device information, and then call as soon as that bridge connection has made. Now there is an intrinsic delay for this because we are waiting for that connection to be made. So if we are on an older device, chances are we'll see a second, maybe 800 milliseconds. On newer devices, this is like 43 milliseconds. So the delay is pretty unnoticeable now, but if you have an older device or a pretty resource-limited Android device, chances are this number, this delay is going to be pretty noticeable. And this was actually a really good push for this cross-platform approach to building apps. Now they have support for iOS, Android, Windows, Electron even, and developing native Mac OS apps. But in their heyday, they had support for things like BlackBerry, WebOS, Tizen. Anyone remember any of these old platforms? Firefox OS? No one? Okay. They had support for literally half a dozen different platforms that you could target. Granted, how many people actually use those platforms? Really, maybe half a dozen people. So since, as of recent, they've stripped back and removed all these legacy platforms and now support on the major ones. iOS, Android, Windows, laptop devices, Electron, and Mac OS. Out of this initial push and this initial release grew this huge community around this. People actually liked Cordova for quite some time. Sure, there were some kind of quirks and weird nuances for how to get things to work, and documentation wasn't always that great. But people grew to learn how the inner workings of Cordova worked and made huge amounts of plugins. If you go to NPM right now and just search Cordova plugins, you're going to get back a lot of results. Like I said, there are some edge cases, though. It didn't age well, being one of the big ones. The way that they would take the plugins and add them to your project was highly customized. If you were to try to say, I want to use this version of a Firebase plugin and then this version of, say, some other Google service plugin, they are kind of just copy and paste each file into the project without using any modern plugin system. This led to situations where you could have a project that says, hey, I depend on this version of this third-party library, but this plugin depends on this version of the third-party library, and those two don't get along. So how do you fix it? You fork the plugin, make the necessary changes, publish it, and now we have 500 versions of a Firebase plugin for Cordova. No one knows which one's the most up-to-date and which one's the best one to use. The volatile project, native projects, if you were to push a project to GitHub, by default, they would ignore the native platforms. So your iOS and your Android projects, all the signing data that is involved with that, the entitlements for push notification, those are not included by default. So you on your computer, you could have one version of the project, you push it up to GitHub, your coworker pulls it down, they don't have any of that data. So now they have to go through the process it is to generate certificates or get their computer set up to be able to sign this app to even just release. And one point that I do want to make sure that everyone's aware of is the overall project health. Cordova is open source, just maintained by people who do it in their spare time because they like to do this. There were contributors from Adobe, Mozilla, Microsoft, Google, and other platforms as well that were helping push this project forward. Since then, a lot of these companies have pulled back support for it. Progressive web apps do have a lot to do with that, but Google has kind of said, yeah, we're done pulling, and we're pulling all of our devs on this. Same thing with Windows, etc. So the project right now is not as heavily maintained as it was 3, 4, 5 years ago. So if that was Cordova, what about projects like React Native or anything kind of in that same vein of write JavaScript and you will generate a native, a truly native project? Well, they kind of bring the idea of if you learn the approach and learn the APIs once, you can build anywhere and write for any platform. And they bring this promise of a truly native app because you are rendering native controls. But really all we are doing is just having a runtime which will interpret our JavaScript and generate all these controls on the fly. Some libraries and some tools that are in this space actually don't even use the native controls. They have a fully customized runtime that they maintain, and as your code gets executed by that runtime, they just draw to canvas. So this idea of having something that's truly native, always put this in air quotes because it's not necessarily true. Architectural overview, we have, instead of a web view, we have V8 or JavaScript core on iOS that is interpreting our entire app. Similarly to PhoneGap or Cordova, there is still a bridge. There is still a way for our JavaScript to proxy calls out to the native APIs and then send that data back to JavaScript, to the JavaScript engine for us to get information back and then render some native controls. So the actual overview is not that much different. There's still a connection between the JavaScript engine and the bridge, so there is still technically a little bit of a delay. React for this case, I will pick on React for now. We can just have a class that extends component, and we're just going to render out these native widgets. So this view is a glorified div. We have text for our replacement for a paragraph text, and we're just going to say hello world. A more complex example is something using a third-party framework called Expo, where we can take an entire camera view and embed that into our app. Things to note is that this camera view has specific native knowledge. So this camera has two implementations, one for iOS and one for Android. So it still needs to know what platform it's on. I want to say this without sounding so mean. Facebook's a big reason why I don't really like React Native. Just plain and simple, it's like that. I think the corporate-driven approach of we are a company, we are building this product for our own needs, and we happen to open source it, and if we decide at some point that, yeah, this isn't something we want to maintain anymore, we're pulling the plug on it, well, now what's going to happen to the community or anyone else who's using this as part of their business? Contrary to what people might say on Twitter, these are actually a lot smaller than as you would imagine, contrary to what people say on Twitter, there's actually a much smaller community of people using these different tools. If you go and try to do some job search, there's going to be a lot of jobs available, but the amount of people who could apply to those jobs or fit the qualifications aren't necessarily there. Varying quality of plugins, and at the end of the day, you still really need to know a lot about native development. You still need to know, how do I take this camera activity for Android or this camera view for iOS, and then set that up and expose it to this runtime. Yeah, not as cross-platform as advertised. This is where we get into Capacitor, and this is our kind of take on what if we took the best parts of a native project and the best parts of a web project and kind of mix them together. So on one end, Capacitor has a JavaScript runtime and a JavaScript API for interacting with different native features. Local notifications, camera, geolocation, etc. You interact with it through a JavaScript API, and then it proxies those calls to a native bridge that pulls in and behaves the same way as Cordova. Where I think this is a lot better than Cordova is the way that these plugins and features are added to the project. So it takes advantage of all the native tooling that has advanced in the past 10 years of these SDKs existing and uses them to its fullest extent. So similar architecture to Cordova, web view, your web app, bridge to proxy between the web view and then the hardware APIs. Things to note, this is not going to provide you any components. Bring your own component library. You could use Ionic, you could use Angular Material, you could use whatever. The API for all this is not a one-to-one mapping to standard JavaScript web APIs. Our camera API doesn't match get media or get user media, whatever the API is called, to actually get access to the camera. Also, the bridge in the runtime is actually loaded before the app has been loaded itself. So there is no device ready, there is no delay between that. As soon as the native app process has been created, that bridge and the web view are already talking to one another. If you need to support something like Android 4.4, I'm sorry. Even as a web developer, Android 4.4 is not a pleasant place to be. We say no, forget that, just 5.0 and up. And for iOS, iOS 12 and 13, and basically current -1. Because iOS devices stay up to date pretty well. I think my iPhone 6 it can't go up to 13, but my iPhone 6 came out like 5 years ago, so I think that's okay. So let's take a quick look at an example. Confirmation in the back, how's that font size? Someone said woo, I'm going to take it. So I just have an Angular project basically here. I already have more or less the pieces to add Capacitor done. So Capacitor is already loaded. The scaffolding has been created for me. I'm just going to create this app, and it's using Ionic, but you don't have to use Ionic. Let's go down. Actually, we'll do this. So we have a little tabs-based application, and then we have this button for add notifications. So let's go to our tab 1 page. And we already have 2 methods in here, an asynchronous ng-on-await, and then this notify method. So let's go ahead and we'll just say const. Oh, I think I have this as a snippet, cap. Yes. We'll just grab 2 plugins, local notifications, and then a splash screen. And the splash screen will become more apparent later on. Let's just say I want to await splash screen dot hide. Because basically we're going to assume that if we are on a native app, we're going to have some kind of launch image that we can show and hide as the app boots up. And then we're going to call await local notifications dot request permissions. Because we are good developers, we're not going to just spam notifications, and because the browser won't really allow us, we're going to request permissions to push notifications to our users. Now that's all set up and that's all good. Let's go to our notify method down here. So we will pull out local plugins, local notifications, and we're just going to use snippets again to schedule a notification. Now this is something that has been difficult to do in Cordova and still is actually kind of difficult to do in React Native, but we have this simple way of saying, hey, local notifications, schedule a notification for me. I can get an array of notifications and show them to my users. It's going to accept a title. It's going to have some text that we could put in the body. We can schedule it at a certain date. In this case, we're just going to say schedule it 5 seconds from now. And then we could attach different things here, like have some sounds play when a notification has been displayed, attachments, actions. So if you get a notification, you swipe down on iOS, you could reply to something, and then any extra data that you want to show. So let's just save this real quick. And because people like to test their apps beforehand, we need to remove localhost and reload. I said we need to reload and get permission. Anyway, we'll just assume that the yeah, that's right. All right, so we'll just assume that it works. So we'll say add notification. I know why. Because I had do not disturb mode on. Wait 5 seconds. Come on, don't fail me now, browser. Oh, this is total demo fail. I got all the bad demo juju from Aaron. Well, that's fine and dandy. It does work, I promise you. Fingers crossed, it does work. Let's go to a simulator instead, because we want to see what this looks like when we deploy it to a real device. So we'll just deploy to an iPhone. It's going to install. We have the app already running. Give it a second. Now, I've already had this request notifications and request permissions wired up before, so it's not going to prompt me. But if I say, oh, here we go. If I say yes, we'll just give it a few seconds. Tap it again just to be sure. Here we go. So we get the notification showing up. We can dismiss it by just tapping on it. We can schedule another one again. It'll just go ahead and keep doing the same entire thing. Now that was, yeah, here we go. We get some actions. We can integrate still with the native notification system. So this behaves the same exact way as a native app because this is a native notification. Now this would actually still work in a browser if my browser decided to not be rude, but we can move on from that and go back to the slides. Now, I added notifications in about 20 lines of code, deployed it to the devices in less than 5 minutes, which I think is pretty good. And the one thing that the other platforms didn't have was progressive web app support. If you want to deploy this to your as a traditional progressive web app, it'll still integrate with all those services. So if you are on Android, you're going to get the same notification experience that an Android app would get. iOS, it's still not fully there yet, but time will probably, they'll add support for that. But for certain features and APIs, you could supply custom polyfills for this. We have a collection of custom polyfills, so if you are on a or if you are on a web device and you want to, say, show a camera UI, you can pop up a camera modal and it will show the video feed, and you can take a photo and it will turn that data back. You don't need to use it so it's not provided out of the box, but if you want to use it, you could as well. And this would target iOS, Android, web, and Electron if that is something that you are interested in. And if you have an existing Angular project, you could just run ng add capacitor Angular. Now, this is something we blogged about in the Angular blog, so definitely give that a read and check out how that works. It basically automates all of this. So just some parting thoughts. Cross-platform people think I can write everything and it'll work all places. Not necessarily true. Cross-platform is, can I have this code that I write replace all the code that I would have to have written for all these other platforms? It's the code that you don't write that's the most important part. We've had a lot of success and a lot of good stories from people who use Capacitor today. And I really think that if you want to do cross-platform development, or if you, as a web team, want to take advantage and dive into this area, Capacitor is a great option, and you can evaluate it and start to build out some pretty good proof of concepts. Thank you.